So good morning, good afternoon, good evening to everyone. Firstly, many thanks to Ian Cassidy and the organising team of Explore 2020 for inviting me to present today. As Helen said, my presentation covers the growing field of artificial intelligence for exploration, which is one that offers plenty of opportunities. And given that I used to work as an exploration geologist, is close to my heart. Unsurprisingly, the pandemic has resulted in a cut in exploration budgets. And as deposits become harder to find, there is a need to leverage emerging technologies to increase the probability of discovery and reduce discovery costs. It's all about speed to value. So I'm going to spend the next 20 minutes talking about the focus of exploration and how far we've come with organic intelligence. What has changed to create the capability to prospect differently? What is possible given the emerging technologies? And finally, summarise the value opportunity. I want to flag up front, and I appreciate that I may be preaching to the converted here, that the purpose of exploration is to realise value through the discovery of mineral resources and reserves with a route to market, and that piece is key. Hence the focus on speed to value and reducing costs. It's important to emphasise this, as for many of us passionate geologists, the reward really is in the discovery and understanding of the genesis of the ore body, but we mustn't, and morphology of the ore body, of course. But we mustn't lose sight of this objective, and it certainly guides all our decisions on spend. It's important also to note that the greatest value-adding stage in an exploration programme for a project is commonly between maiden resource and feasibility study. So the ability to accelerate these stages and enable better decision-making is key to bringing down discovery costs whilst maximising value generation. Before I talk about artificial intelligence, it's worth pointing out that geologists have been undertaking analytics literally since the Stone Age. Traditional prospectivity analysis is analytics in the same way we program machines to do it today. Identifying patterns and trends based on previous experience and correlations is machine learning, except the human brain in this case is the machine. And as geoscientists, we've been using advanced software and geostatistics for decades to model deposits. So what has actually changed? Well, we've had exponential development of technology in the last 20 years, with a convergence of several disruptive technologies that have really changed the way we both live and work. And these are IoT, or Internet of Things, which is really another way of saying connected devices, and smart machines. Big data, analytics capabilities, and visualization tools, which are critical to how we do our work in exploration and enabling us to see what the data is telling us. And then mobile platform and cloud technology. And if you look at this figure here, this was actually put together as part of a piece of work Accenture did with a World Economic Forum back in 2017. And the work was really looking at the impact of digitalization on mining and metals. And when we talk about mining in Accenture, we mean the mining companies that have an exploration division as well. So we're not just talking about the operational stage. And as you can see, back in 2017, which is not all that long ago, the projected development of AI was down here and was nowhere near the technologies that are really now relatively mainstream and are being widely embraced. What has happened is AI is developing and has become industrialized far more rapidly than we initially anticipated. And it really is up here now, close to IoT, big data, platform, cloud, etc. The potential is huge. And if we consider that the iPhone only came out 13 years ago and the Android smartphone came out a year after that, how much the way we live and work has changed just simply as a result of having smartphones, we anticipate that the change we'll see as a result of AI over the next decade is going to be extraordinary. And no doubt the pandemic will have accelerated that. So what is possible when we talk about artificial intelligence? And for anyone not familiar, artificial intelligence really is, in simple terms, the field of computer science where machines are programmed to think like humans. And there are many different approaches and techniques, one of which is machine learning. The most obvious application is with large data set query, looking for correlations and trends. So looking for correlation between, as a geologist would do, is host rock age, regional fault structures, intrusives, the go-to neurology, of course, but obviously doing that at a much faster pace. And fuzzy logic can be applied for prediction and reasoning when information is uncertain and data is incomplete, as often is the case with historical data or early stage exploration data. So it's actually quite fit for purpose. The predictive capability of machine learning is very powerful, and machine learning can be applied to known data to train and test the model. So that the dataset query and correlation phase is termed feature engineering, where you identify the clusters of the features according to some program parameters, and a probability and weighting of data points can be added as a prospectivity rating. And once confidence in the model is fit for purpose, so that will differ depending on how advanced the project is, it can then be applied to unknown data. And this is an iterative process. The model can and should be continued to be refined with additional data and reinforcement learning. And there should always be a validation step with feedback from geologists, geophysicists, metallurgists, etc., depending on what stage your project is at. So it's really critical that what we're not saying is we're trying to replace geoscientists. What we're doing is augmenting the work that the geoscientists can do, but it's very important to ensure you have this validation step. So in considering where artificial intelligence can be applied in the realm of geoscience, the options really are numerous, not least as you're often working with large volume data sets, potentially incomplete data, multiple data types, unanalyzed historical data, and some of the key data inputs, particularly for applying machine learning to an exploration stage project, are listed here below. Some of the key opportunities are it's very quick to query, you can quickly identify trends and patterns, and therefore the machine learning improves your deposit intelligence for that informed decision making. So now I want to talk you through several areas where we've been working with clients to develop artificial intelligence for geoscience data. And one of these is the Geoscience Intelligence Platform. Exploration projects often have vast amounts of data that are not readily accessible or usable. We're all familiar with that. And these may be historical hard copy data or data in different software systems and formats where interoperability is an issue owing to a lack of integration of the data sets. And it's often challenging to extract data and information based on the geological, geophysical, mineralogical attributes. It's not possible to run queries simultaneously on multiple different data sources. And geoscientists often carry out the tedious manual work to search for and collate data. It's especially difficult to extract data and knowledge from text documents and then couple that with numerical data, particularly, or geographic data. And few tools deal with unstructured documents and reports. So costly analysis may not include all essential data, making conclusions incomplete or, even worse, inaccurate. What we do in terms of the Geoscience Intelligence Platform is we work with clients to create this platform aligned with their IT architecture and data sources to solve for these issues we've discussed. So this is not an off-the-shelf platform. This is something that we put together using standardized solution architecture, but fitting with their IT architecture, so their internal IT architecture. And in many cases where we've worked with clients on this, we have used, where they have had hard copy data, we've digitized that and extracted the information out of that by annotating the documents itself and classifying that, by extracting text and using optical character recognition to pull out that text from these hard copy data, classifying the text. You can classify images within that data, within those documents, geotag, vector shapes, vector text, apply word vectors, and also topic clusters, which is really key for then developing the user journeys. And when we talk about user journeys, we're talking about those who are going to end up, so the geoscientists who are going to end up using that geoscience intelligence platform, we always work with them to understand the way in which they're going to use it, and what kind of things, what outcomes, what value they're trying to generate from it. So we can then design the interface accordingly with an appropriate index and an appropriate search engine. So they really can get maximum value out of all of their formerly hard copy data and their digital data. There's a clear value opportunity here. Obviously, in the process, you're going to increase company-wide access to clean digital data. You will shorten your target identification, exploration, development, and planning cycles, and certainly reduce geoscientists' search time and catalogue of archive data. And you can use that data to unlock value and decrease discovery costs. And there's also an opportunity with some of the clients we work with. They really did have a large quantity of hard copy data that was then scanned, and those that needed to be retained were centralized. So the overall document storage costs were reduced significantly. And overall, having access to all this data and the capability to generate the insights, so that the knowledge out of that data, it gives our clients a competitive advantage when they use the geoscience intelligence platform approach. Another area we've been creating capabilities with clients is by applying machine learning to geological modelling. The example that's shown here, these are some very early outputs from a machine learning model where we were modelling based on the drill hole data set, so the exploration drill hole data set of a porphyry deposit. And what you see there is definitely not where we got to in the project, but that demonstrates without any guidance whatsoever, that was what the machine learning model was capable of producing. And what we did was we developed a procedure to identify and model, to create 3 different models in the case of this particular deposit we were working with, structures, lithologies, and ore types. And we applied the machine learning techniques alongside a number of deterministic rules that were really geology and exploration 101. And we modeled obviously the geology, unconformities, any fault displacements and offset, ore type distribution. And the output of that machine learning model is a point cloud. So you have the known data points, obviously from the drill hole intersections, and the machine learning models creates the data points in the projected data points in between those known data points so it comes out as a point cloud. And in order to make that usable in the client's traditional modeling software, we then rendered that into a 3D solid. And that was a process we automated to ensure that it was an integrated solution rather than multi-step. This is very much still in development, and we're keen to progress our understanding of this. What we want to do with geological modelling is not automate the way a geologist does it, it's to apply machine learning and other artificial intelligence techniques to geologically model differently. And so by automating the analysis of the drill hole data and that generation of the geological model, there's the potential for significant reduction in the end-to-end time needed from drilling to resource estimation. But there are also a number of other significant benefits. So one is improved accuracy by enabling that quick visualization of the geological model and iteration as data set increases. So because you develop the model in a much shorter time frame, you can actually run that model based on limited drill hole data to give you a ballpark view of what the deposit is the morphology of the deposit and the distribution of mineralization. And that then will inform your drill plan during the drill program. So you can make more evidence-based decisions, data-driven decisions, and lower your your overall exploration costs. It reduces the time for the model to be the output of the model to be generated, and therefore moves you towards that maiden resource and update resource much faster. And what it also enables you to do is it creates a predictability to the process of geological modelling and a standardization of that modelling. So as geologists, we're all going on our experience, our training, but also there's an element of intuition and understanding up over time, and that is very hard to capture. But if you're able to standardize that process of modeling, you're able to improve the quality of it, because you can pick up on any errors in the data that may be there, errors in the interpretation itself, because we're maybe geologists, but we're not infallible. So it is possible we could make a mistake or potentially miss data points and material features in the deposit.
I'm sorry, Liv, there seems to be a small problem with your microphone. There's like some...
Can you not hear me?
Some background sound. Okay, there it seems to be okay. I don't know what we're with the connection. Thank you.
Okay, thanks. So in the interest of time, I'm not going to go through this in any detail, but I thought it's good to highlight what others are doing. Accenture operates very much with an ecosystem approach. We're all trying to solve industry problems or improve the way we do things in the industry. And therefore, we're always really pleased to see what others are doing and work together with others. So I wanted to highlight that there are lots of emerging technologies that are enabling improved access to data, and to which artificial intelligence is applicable for the all-important speed to value. And a few examples are sensors used to better qualify drill core samples, AI models used to ensure consistency between drill cores being logged for a given borehole or drill hole and previous logged ones in the vicinity, machine learning algorithms used to extrapolate between drill hole data points to create sections, so to automate that section creation process, AI target generation, hyperspectral imagery, which I think we heard a little bit about earlier on today, which can be a data source for machine learning, and then you can couple it with other data. Also core logging from high-res images, in situ elemental analysis, which can then be automatically fed into a machine learning model for geological modeling. So the options are endless, and lots of companies are working on developing this. So I think it's a really exciting field to be in. And interesting, I just wanted to point out Unearth there, which is a platform for data science and artificial intelligence, earth sciences, so earth science specialists, to access real data and innovate, which I think speaks very well to how we approach digital innovation these days, and being able to share access to data is important for advancing ourselves much faster. So in summary, the value opportunity for artificial intelligence in exploration is considerable. AI can quickly identify trends and patterns, increase deposit and extension discovery and definition, and decrease the time in which you get to that point, define mineral distribution with greater accuracy. And actually, ultimately, I know this is an exploration conference, but exploration does lead to mine, and it has to lead to mine to generate the real value from extracting the resources. So ultimately, it helps improve mine design and lower dilution for more efficient use of our natural resources. Accenture's purpose is to deliver on the promise of technology and human ingenuity. And this ecosystem approach I talked about, working together with our clients to improve how we find the minerals we need in the most efficient manner, is something that we're really passionate about and will continue to invest in. Thank you.